It's iffy. Okay, for the sake of time, some of these questions are probably going to take me a hot minute to do. So I'm just going to go ahead and get started. Anybody who misses it can catch up later. He went through so much today, it's unreal. All right, so if you take the derivative of this, you get infinity, or if you take the limit, you get infinity to 0 power, which is indeterminate. So he went over this today, and that's why I kind of sort of got lost. Can y'all hear me, by the way? Okay. I know the audio is bad, but I had some interference problems, so he did. I'll go down to see it. Go down to show you. He went over this. For a complicated limit, take the natural log of f of x. Take the limit as x approaches a, and the limit of f of x as x approaches a is e to the l. So that's what we're going to do up here. So a limit 0 infinity 0. To x over 2, I think. Okay. We went over this Monday and I was completely lost because I had forgotten how to do it. He's not nice with the L'Hopital problems. So since it's indeterminate, we can take the natural log f of x equals x over 2 natural log. Oh, never mind. I won't skip a step. Natural log of e to the 6 over x plus 5 to the x over 2. All right. And working my way sideways, that equals x over 2 because that right there can be moved up front. Sure, log rules. Natural log of e to the 6 over x plus 5x. So now we take the limit of this, but that still won't work. So actually, I'll just write it out. Take the limit 0 of nope. Forgot the natural log. This will still equal 0 times natural log of infinity, which still equals 0 times infinity. So instead, let's take the limit of YouTube has the juicy stories that it likes to recommend me. Natural log of e to the 6 over x. This is x over 2. So you can move to the bottom. You can flip it by moving it to the denominator and write it as 2 over x. Everybody see what I did there? All right, and now we can do L'Hopital's rule. Equals so you get for the numerator you get 1 over e to the 6x plus 5x times negative 6 over x squared plus 5. Oh, wait, no, that's wrong. There you go. You take the derivative of e, the derivative of the function times e. And you take the derivative of the bottom, which is negative 2 over x squared. Now, I haven't got this far on the problem before because I get to this and I usually get mad. But simplifying as much as we can, get negative 6 over x squared e to the 6 over x plus 5 over e to the 6 over x plus 5x times, you can flip this, x squared over 2. Just keep it, change it, flip it. Wait. Negative. Those negatives will drop, but so what you could do right here, and since it was a natural log, you have to do 0 plus because you can't have a negative number. So it can only be from the right. And don't forget your limit. I may have done this completely wrong. It's not easy with these problems. Even like did I take the derivative right? I had to. Let's simplify. Negative x squareds will go together, so that's 6e to the 6 over x minus 5 over x squared over 2e to the 6 over x plus 10x. Somehow this is supposed to equal 3. So if you plug in 0 here, you get infinity minus 0 over infinity plus infinity. So that's infinity over infinity. So that still won't work. So let's take the derivative again. See what happens. I may not have had to take the natural log of this. I did. Yeah, still 0 over infinity. So I did have to do something. We may just give up on this so I can move on to the optimization problems. I'm just taking the derivative right now. Yeah, the answer is e cubed. I can graph it and find that, but I'm trying to figure it out algebraically, and I couldn't solve it yesterday. I'm trying to use the method he went over today, and it's just not working. Did y'all figure out how to solve it algebraically? This problem is stupid. Because now you have 0 times infinity plus 0 over 0 times infinity plus 10. And that's not going to solve the problem by just keep taking the derivative. Because the e never goes away. Yeah. You can really just graph it. It's e cubed. I'd like to see him solve that, because I don't know the method that he wants us to use. Okay, we just know it equals e cubed, the final answer. I may try to solve that one later because it's starting to make me mad. So what I did yesterday was just graph it. So this one, you get 1 to infinity, which is technically indeterminate. But fun fact, that still means 1 to infinity is actually e. The limit as x approaches infinity for like 1 plus 1 over x. But this one, answer's 1, but we're going to solve it. So natural log of 1 plus 2 over x to the fourth to x equals. So we're going to do natural log of and it's going to equal to the fourth times -8 over x to the fifth all over -1 over x squared. And that equals I think I know what I did wrong. The top one. No, I didn't do that wrong. Never mind. Okay. So since this is in the denominator and that's in the denominator, you can actually cancel this out and that and change it to a 3. So you end up with limit. That is the ugliest infinity. And that equals 8 over infinity. Huh. Which technically equals 0, but the answer is 1. I know that. I solved this one earlier. Relatively easy. Do y'all just want to go into the word problems and stop watching me struggle? Okay. Yeah, sorry about that. After I get past the word problems, like the rest of it's super easy. It's just, all right, so when you're working these word problems, always draw a picture, always. From a thin piece of cardboard, 50-inch by 50-inch, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume and round to the nearest tenth? Okay, so for this one, I believe the box does not have a top to it. Don't quote me, but every single question I've been asked in the past, the box does not have a top. The box may have a top on this one, I may be completely wrong. So, we're gonna draw a box. Well, first off, we're gonna get our equations. We don't even really need to draw a picture, but we have a two question. We have surface area equals a squared, and that equals 2,500, which is squared. I know. And then we have volume, which equals length times width times height. But he wants the corners to be cut out of it, and so you have a square. Yeah, boom. Do you guys agree that this is how you make a box? And you're missing corners, which I'm assuming are these. And you have length, width, and height. And this is 50-inch. He's not nice with these questions. I've never been asked these things like this hard. 50 inches. So that's all the equation you're getting me. So surface area equals length times width plus two lengths. So this is a length over here. This is a width. Height. That's actually width up there. And this is like width, and this is length. So you get length times width plus 2 length times height. So you can get the surface area of that. Plus 2 length times width. And of course, your volume equals length times width times height. So now you have two equations. But now you have the original equation, so you have 2,500 inches squared. That has to equal this equation. So I'm just going to put SA minus corners. So and each corner is like 2 length times height and 2 length times width. Actually, no. These corners are all h squared. And this right here is wrong. This should be h. Minus, and you have all these, this h times w. is h times length. It's h times w, and it's h times length. I don't know if y'all are following me. This is kind of a lot, and I can't really write it all in one area. So minus 2 length times height plus 2 length times width. Height times width. So what's cool about that no, that didn't get us anywhere. It's plus. That's what I did wrong. You gotta add those two together because you got the surface area on the first one, and then you surface area of the box, and now you have the surface area of the corners. So you gotta add them to get 2,500. So four length times height plus 4 height times width. So that's equation number 1. Now we have volume equals length times width times height. We don't know the volume, and we don't know length, width, or height yet either. Actually, what we're supposed to do is take the derivative, right? Fun fact, I went to like all these online things to solve limits, and those first 2 problems, they couldn't solve it. We don't have to take the derivative for optimization, I didn't think. I think I did that wrong. Okay. He did this one like this, and I tried to do my own way. There's too many. I didn't draw a picture. There's too many variables. So now we know we can draw a square or a rectangle. So never mind my bad drawing. So now you have the height h, and then it said the corners cut out, right? Yeah, so I started looking at. It said the corners cut out, but we didn't say they were exact length, but they'd have to be the exact length. Then we have width and length. Volume equals height, so h times 50 minus 2h for the length. So you have your h here, your h here, and your 50. So 50 minus 2h times, and your width is the same thing, 50 minus 2h. I was trying to do it a different way with the surface area. So V equals H times 50 minus 2H squared. So now it equals H times 2500 minus 2H. 50 minus 100H. So V of H equals this is going to be a long session. I want to finish this thing. Plus 4H squared. That's what the 50 was in there for. So now, optimization, you want to get the maximum amount of volume. So to find the mins and maxes, we have to take the derivative. Everything involves a derivative. When we get to integration, I swear I'll be better. And now we set that equal to 0. I'm going to go online to factor this to save some time. Good job, Mathway. You can't do it either. You get H equals 50 plus or minus 25 root 2 over 2. I had to change this earlier. When I distributed the H, I forgot to write a cubed right here. So I wrote 2 instead by accident instead of 3. But then when I took the derivative, I multiplied. There you go. I see what you're saying. I wrote a 2 and didn't change the rest of it. Thank you. You could factor out a greatest common factor in this one. So once you have that, go to your number line. over 3 is 8.33, and you have 25. So for your derivative, you can plug in, let's say, a 0 to the left, and you'd get a positive number. To the right, you can plug in, or in the middle, you can plug in 10. You get 2,500 minus 4,000 plus 1,200, so that's a negative, so it would be minus 300. And then to the right of it, you can plug in 50, and you would get a number so astronomically large because of the squared, it'd be positive. All right, so now what do we know about going from positive to negative? This means a local max, local min. Okay. And actually, this is going to be an absolute See, it's increasing, then it starts to decrease, then it. You did the second derivative. So if we go to the equation, oh, we also have never mind. So if we go to the equation, v of x or v of h equals h times 50 minus 2h squared. We have our critical points, and this is the maximum and this is the minimum. So if we plug in 25 over 3, I got 9259. Is that what you got? Is that even over here? Yeah. And 8.3 inches. So H. Now what we can deduce from this, or from this over here, 50 minus 2H equals W. So that equals 50 minus and then length equals 50 minus 2H as well. I hope that was the right answer. All right. God, this has been the longest 35 minutes, I swear. We're only on question 4. A private shipping company will accept a box for domestic shipment if the sum of its length and girth, distance around, it's a perimeter, does not exceed 90 inches. So volume again, length times width times height. You have your length and you have your width. Then you have your height. All right, your girth, G equals 2H plus 2W. Oh, your perimeter, we'll say girth. And that cannot exceed 90. All right, hang on. So, we're going to say equals 90, actually. The girth, now the girth does not have anything to do with the length, you see? It's just the width on the top and the bottom and the height on the other two. So the girth doesn't have anything to, the length doesn't have anything to do with the girth. I wouldn't think. Yeah, the girth is a perimeter. So it goes around here. The girth has nothing to do with the length. Hang on. Wait. Okay, so length and okay. So girth. Okay, I see what you're saying. I didn't read the question. And so length plus 2h plus 2w equals 90. And it's a square end. You see this right here? So h equals w. So length plus 4x equals 90. X equals h comma w. And since it's a square end, you have this. Okay. So length equals so we're just gonna go this. So length equals 90 minus 4x. All right. So now we go to our volume equation. Volume equals 90 minus 4x times x squared. Since w equals x and h equals x. Y'all see what I did there? Okay. So now you have a function in terms of x that we're all used to and love. So v equals 90x squared minus 4x cubed. V prime equals 180x minus 12x squared. So now x times 12x times negative 12x times x minus 180 divided by 12 is 15. Yeah. It's minus 15 equals 0. So now you come number line. You have 0, 15. V prime equals 90 minus 4x times x squared. So if you plug in a number less than 0, so let's say -1, 90 minus 4, which is still positive, times -1 squared, which is positive, so positive. So you plug in 10, 90 minus 40 is positive, and 10 is 10 squared, that's positive. And let's say you plug in a number greater than 15. I may have done that completely wrong. So that's still positive. A number less than that shouldn't be. It should be decreasing on the left. Okay. Where did I go wrong? That's the derivative. Well, yeah. I plugged it into the wrong equation, guys. Y'all didn't catch me. I preached this. Equals -12x times x minus 15. Y'all didn't catch me. So now you have a negative. So if you plug in a negative number, you have a positive and a negative over here. So that's going to be negative. You plug in 10, you have a negative, and you have a negative. That's going to be a positive. Negative times negative. And now you plug in, like, say, 20. A negative and a positive, that's going to be negative. So we know right here, max, because it goes from increasing to decreasing. All right. So now we go to the original equation. So V equals 90 minus 4x times x squared, and plug in 15. 90 minus 60 times 225, which equals but it doesn't even want the volume, does it? Anyways, now we know h is 15, or so now since we know x is 15, we know length or width equals 15 and height equals 15. Right? Yeah. And now we know that length, since going back to our equation over here, equals 90 minus 4x. 90 minus 60 equals 30 inches. All that's in inches. And B is the answer I got. So I'm going to keep going. This one I saw and it didn't make too much sense for me. The price charged per candy bar is P of X cents. Then X is rounded, is the thousands of candy bars. Shut up, man. Oh, God. To be sold. To be sold in a certain city, where P of X equals 24 minus X squared. How many candy bars must be sold to maximize revenue? So P of X is revenue. Because that's how much is charged per candy bar. So P of X equals 24 minus X over 22. I don't like this problem because obviously 0 is the maximum. It will maximize revenue. So when you want to maximize, you have to take the derivative. Equals -1 over 22. And I think this is how you work this problem at all, personally. It only gives you one equation, doesn't it? So it's decreasing over the entire interval, so that's why I don't like this problem. Did you guys understand this problem? Because there's no other equations. Do y'all have any input on this one? Yeah, he gives you a. Okay, so the answer is D. He gives you in the examples. He gives you two equations, right? He only gives you one problem here, like one equation. So that's why I don't understand it. And according to this, the less you sell, the better, because it's a decreasing linear equation. So 24 minus, this is why this doesn't make sense, 264 over 22, that gives you 12 cents to sell 264,000 candy bars. I mean, $528,000 candy bars is when it hits the x-axis. That means there's zero revenue. This is linear. It doesn't make sense to me. Sorry. I'm going to skip that. I may ask him about this one. And then I'm going to do a test review. And then I may go over this problem like towards the end of that, if I can get him to answer it. Okay, so how close does the curve come square to x? 3, 0. I'm going to do the test review probably early, but I'm going to have it set to go public on Sunday, probably like 6 o'clock Sunday night. That way people are incentivized to do the test review themselves. That's what I did last time, because y'all need to practice yourself instead of just following along. And obviously I'm no help right now. And yeah, I'm going to do the practice test. I'm going to do it on my own time. Like, y'all aren't going to see it during a session or anything. So I'm just going to do it and talk through it and hopefully have my microphone on. So square root of x, so square root of 3. How close does the curve y equals square root of x come to the point 3, 0? So let's I don't like this one either. 3 square root of 3. 3, 0. You would think the straight line would be the best, but apparently not. You would think it'd be square root of 3. Let's just do y prime equals 1 over 2 root x. And your CP is 0. So if you come over here, 0, you have a negative number, does not exist. You have a positive number. Well, this is always increasing. So did y'all know how to do this one either? These questions I've never been asked before. And I'm in engineering. And I've been through 3 calculus classes. You graphed it? If you minimize the square of the distance, over here it's 3 units away, but right here it's root 3 units away. And my best bet, it would be B, because x can't be negative. And it's not 3 units away when x equals, it could be 3 units away. What did y'all get, A, B, or C? No, it was B. Okay, that would be my guess. Hey, finally something I can do, guys. Yay. I'm just gonna ignore that. If y'all are graphing it, that's what I would do. So, antiderivative. Remember the integral of n a to the n x to the a dx equals n times 1 over a plus 1 times x to the a plus 1 plus c. So for this one, you have 4 over 7 times 1 over 6/7 plus 1 times x to the 6/7 plus 1 plus c. You don't even need the plus c because it's antiderivative. So you get 4 over 7 times 1 over 13 over 7 times x to the 6 over 7 plus 1. These 7's drop. And this is actually 13 over 7. I don't know why I did that. And it equals 4 over 13 times x to the 13 over 7. C. Yeah, I felt confident again, guys. So, and here you're taking the general antiderivative, so you're doing the same thing. Just do it like this. X to the negative 3 minus x cubed minus 1/2 dx equals 1 over negative 3 plus 1 x to the negative 3 plus 1. And then I'm just going to do this. Minus 1 over 4 x to the 4th is 1/2 x plus c equals negative 1 over 2 x to the negative 2 minus x to the 4th over 4 minus x over 2. Plus c. Oh, yay. So this will equal the integral of 6 times 1 minus x squared to the negative 1/2 minus 7x to the negative 1 dx. So you take the derivative, 6 times 1 over 1/2 plus 1 times 1 minus x squared. How does he expect you to do this? Did he teach y'all U sub while I was in the bathroom? Oh, wait. You can distribute the integral out, and this equals 6 times sine inverse of x minus 7 natural log of x. Any questions on how I did that? Or do y'all understand? And it's absolute value of x2. You can't forget the absolute value. This is this right here is the derivative of sine inverse of x, and this is x to the negative 1 is a derivative of natural log of x. If you have any questions, please let me know on that one. Solve the initial value problem. So the original equation at 1 equals 2. So take the integral of dy dx equals negative, let's see, 1 over negative 3 plus 1 times x to the negative 3 plus 1 plus 1 over 1 plus 1 x to the 1 plus 1 equals negative 1 over 2 x to the negative 2 plus 1/2 x squared. Now we know that plus c. So now we know that y at x equals 1 equals 2. So y at x equals 1 equals negative 1/2 times 1 to negative 2 plus 1/2 times 1 squared equals 2. Oh wait. Plus arbitrary constant c equals 2. Negative 1/2 plus 1/2 plus c equals 2. These drop. C equals 2. Any questions on how I did that? I know I'm going kind of fast. If y'all are following, that's great. And so you keep the original. So now you have C. Given the velocity of a body moving along the coordinate line t, find the body's position at time t. So ds dt equals v. And that equals negative 19t plus 8. So if we integral of ds dt equals s. So the integral of negative 19t plus 8 dt equals negative 19 over 2 t squared plus 8t plus c. And now we have s is 0, so s of 0, let me write it like that, equals 8. So s of 0 equals negative 19 over 2 times 0 squared plus 8 times 0 plus c equals 8. 0, 0, c equals 8. So now we have that s of t equals negative 19 over 2t squared plus 8t plus 8. Answer is B. All right, we finished about 1 minute late. Any questions on the last few that I actually knew what was going on? I told y'all I hated optimization, but I will have office hours tomorrow. We can try to solve some of these other problems if y'all have any ideas. I like how half the test out or quiz I was useless. I really don't know how to solve this one at all. I've never seen a question like that. This one, he only gives you one equation. So, yeah, I don't know what to do with that one. Finally figured out this one. This one was a long process. I guess y'all can go about and watch it. But it helped because it was a square end. And this one took me a while. And these two, I don't even know. I graphed them with Desmos. Somehow that equals e cubed. The limit equals e cubed. So any questions over anything, SI or anything else related like that? All right, if there's no questions, we'll see y'all either tomorrow or Monday or whenever, because y'all have a test on Monday.